Okay, so here is my second project level that I ended up doing. This incorporates my trigger project that I ended up doing first so that we had a little bit more interaction and we actually make more of a complete level because this whole secondary project was about adding ambiance and adding more effects to polish off our overall concept and make an interesting level. So I'm going to start off with playing it and then we'll get into how it works. So first off here, we end up in our first starting area, and as we enter, we get our WASD to move and press 1 to see number of keys, which we have is 0, as we did before. Now, we have press E to interact with the box, but I want to see what's going on ahead. It's pretty dark, so I'm going to go and I'm going to go and turn on the lights. So let's do this, and it actually turns on our lights that we made from our array, and also adds in one of our newer effects, which is these particle effects that we have going from some of the lights. You might be able to see them over in the corner there too. And also we have a new prompt that we add, which is interact with certain objects with right click. And if we see when I right click, we have a little red line going through. I'll explain what that's going on about in a minute. So the next thing is we have our door still, and it says door opens automatically if you have the key, and it still doesn't open because our number of keys in our corner is still 0. So if we go over here to this area, we'll notice that we have our elevator. Now our prompt, because I didn't modify the size or the origin point of where this was on the thing, we can't see all of it, but it says proceed to interact with buttons on elevator if it has power. So if we go over here and see, we have no power. So we can't actually use our elevator. So this is our little puzzle here that we end up doing. So the weird interactable object is this thing that's just sitting here out in the open. And if we press right click on this, it actually picks up the item. Now we can shake it around and do as much as we want with it, but we can't actually interact with it in this state. It is actually a non-collision object for us. We don't collide with it. And then we can't even fling it because we edited how it works so that it immediately drops so it doesn't get thrown very far. But we can pick it up and manipulate it however we want. So I'm just going to drag this over here and put it on the suspicious looking tile, which then says power seems to be on, which now, our puzzle completed, we can now use the elevator to ascend to where the key might be. Then we have our special flickering light over here, which we did all with code, so that was pretty cool. And I have a few more effects that you get to see every now and then for our particle effects going through it. And then if we look over here, step near items to pick them up. We have this. I only have the red circles, so we know that that is the pickup area for the moment. And once we have this, and we check on our number of keys, it is now 1, saying we have 1 key. Now, if we come back over here, and we go to the door, that is our level finished. The door moves up, and we have completed the level. Now, how I got some of these new little things to work and got some of the stuff to actually function correctly with what we originally had, we had to do a little bit of modification along with adding in some new stuff. So first off, we had to make our sparks, which each one of these is adding in quite a few extra variables from initial local seed, constant acceleration, size by speed, its light seed, so it actually emits light, and also its actor collision, so we get a little bit of a bounce on our sparks, so that they have a little bit more life to them. Then we also had to modify its lifetime, spawn rate, and a bunch of it's required, along with changing the colors for what it does, because it goes from a nice bluish at the top to then more of a warm red as it heats up. So that was what we had to do with sparks to get our initial spark, and then each one of those is slight variations to what they do. And each one of these, if we look at it, we have one that is kind of a constant stream, Then we have another here, which if we look at that, is less of a stream, and it has a lot more variation in where the sparks actually go. Then our last one is just little spurts alternating between a few of them to give it a little bit more randomness, and they kind of fade off into existence for all three of them. That was how we did those, and then next is our point light, which is our flicker light that we have made, which if we go into our blueprints here and we look at point light, it's basically begin play, so as soon as the game begins, our light component, we're going to be changing its intensity of that. So that was basically how we got the flicker, because intensity is how bright or dim the light is. So what I did was I strung this a random float variable, so it would change it randomly at whenever this would happen, from a minimum of 0 to a maximum of 1,100. So it gets a full range of what the light can do. Then we wanted this to be a little bit more random and actually keep going. So instead of just on game start, it would be different every time. So then we put it through a delay, and then this delay feeds back into the intensity, so it resets every certain number of seconds. Now the thing is delay keeps it a constant for its normal thing. So we also put a random float range in this, so that we have a min of 0 and a max of 1 in seconds for when this will update and keep updating to give it the variation of something is really wrong with this light and adds a nice bit of accentuation to it. So it really seems like it is random because it's random within a range of things that the computer chooses as it updates throughout the game. Also, we have all of our original stuff. We have our door here that was the component begins on box overlap for us as the character, and it checks our number of keys, and if from the specified number of keys that we have, it then opens the door and plays its lerp vector, because I wanted to try something other than matinee for this. So that was this experiment, and it works out fairly well. And then we have our key for this is setting up when we pick up the key. It then adds that to our number of keys for our inventory within our first person character over here. And it has our perch string, which then is our number of keys integer. Because that's basically all this is our inventory has an integer that it keeps track of, and we have to print it to the screen to even see it. And then that gets modified and allows us to see how many keys we have to then conditionally open said door, because we could have this set as 3 keys needed to open one door, or the 1 or 0. Or we could do it at a random value per game, per playthrough, to make it more variable as it goes. Also, we have our original light switch, which was our toggle light event on our array, which then toggles its visibility so we could see it or not see it. So we have everything set as not visible initially, and this just toggles that to be on. And this was based with our custom toggle light event, which, if I can remember where I put that. That was here. So this was our, where did I put that? I don't even remember. Oh, here it was. Our toggle light. So we basically everything over here on our light switch is for our custom events that we made for our toggle light, and then it goes over here and specifies that on overlap and pressing E, we then get our light switch to toggle our custom variable, which then toggles the internal stuff. Now, getting back into what we ended up doing for our lights and our particle effects, to get them to turn on and off, I actually used the same exact system as our lights. So if we look over to what we have below and to the right, it's basically the same exact thing, except we set this as a emitter object reference, and then we look into its particle system component instead of light component, and then do the same thing with toggling its visibility. Now, the only thing is because we couldn't overlap these two together within the same trigger box, if we go back here, I had to use a trigger emitter toggle instead of trigger light toggle, so we have two overlap toggles for two overlap triggers over the same thing, but it activates them both at the same time anyway, so it was just a matter of getting it so that it does that. Also, for the next part, for our little puzzle, we had our elevator over here with its standard matinee up and play in reverse for down. All we needed to do to get this to work is, because you can't access it while it's up and it's in its starting position at the ground level, we just added a custom Boolean variable here, which was power on. It's over here, and this is universal in the build. So what ended up happening was, when we have our trigger box overlapped with the battery specifically, because that's what it looks for. We don't want it to trigger with just the actor. We want it to trigger exactly with the battery. We have it trigger with the battery, which then has a 1-second delay that then has a print string and the sound of the power going, played from the source of the battery itself, to then toggle our Boolean to be yes. That is all that is. And then down here, all it is we have the conditions of we have to press E while overlapping, and our branch says we need our condition to have power on. And then it plays the matinee. So if this does not meet, even though all these things do meet, it still will not activate. Otherwise, this does not need to be changed. And we can even add in some extra variation to this, that if we move the battery off again and we have some other puzzle, we can then make it so that this still will not play because it is not overlapping on that trigger box. So we set it so that, hey, if you're not overlapping, then you turn your Boolean back off. That is all we need to do for that. Now, the next thing we had was actually integrating the sound, which was very, very simple. Going back to our blueprint, it was basically just saying, hey, play this sound at location during this event trigger. And we had to make it custom so that it doesn't loop consistently, but all that was changing the attribution of one of these sounds with not loop, and that was basically it, because the sound was long enough for us to actually use what we needed. Otherwise, this is what the level looks like with all of the lights off as intended for the start of the level, except for our main starting area. And back to what we had for our actual our trigger battery power. That we used with code, and that was all about our interaction that we have. So that was all done within the first person character. And this was all inspired actually by my toggle trigger with vector look to try to get our light toggle to work, which I used the base premise of this and actually figured out what was wrong to get it to work. So what we ended up doing here was we had to make quite a few custom variables. Down here we have our drop feature, we have our pickup feature, we have our initial yes-no pattern of if we have our right mouse button clicked or not clicked, for if we are holding off of our custom Boolean, which says if we are holding the object or not, and our set grab location. All of these were imperative to make sure that this actually worked. first off, we have our right mouse button going into our branch with the condition of if we are holding this object or not. True, we use interaction drop, and if false, we use pickup. Very simple. Our next one, this was actually using our vector to then pick it up. So what we had to do here was we had to set a grab component. So that's where our set grab location comes in. So this was imperative to building the next piece of this code. So what we had was every tick, we're going to set our target location as our grab location of the world, of our world location. And we're going to use our physics handle as the target. Now, this was actually something we had to add in with our grab location here and adding in a physics handle component. So this way we can actually move objects around. Otherwise, this was very simple to add in because literally all this grab location is, if we look in the viewport, is just this little invisible box at the top here. Now, this is our focal point for where we actually will hover our object. This is our main area where we do that. Now, going back into the events, when we look at what we have down here, for our pickup, this is a little bit different because for our pickup, we need to go into a line trace for objects. But what we need to start this out is we need to get our line trace. So what line are we using? We want to use our forward vector of our first-person camera since we're the one interacting. So we use our first-person camera, and we have to get our world location and our forward vector. Then we have to have our forward vector be multiplied by a fair bit so that it actually extends out past where it connects with our player. Then we also have to return our value to our start and end point. So our start point is literally going to be where it starts. So that just goes straight in. But then our out for where it ends gets added together with our float value that we ended up doing for our forward vector of how far a forward vector moves. And then that gets put into the end. Then we want to make sure that we're only looking for an array in our array of physics bodies. This way we can only interact with those, and this allows us to actually designate this later that it actually will look for that specific object. Because if we were trying to make it look for a specific object and we didn't have the blueprint of physics body for it, it won't actually work for its class. Then we set all this into our branch of yes and if we get that return value. So we need our return value of hitting our physics body for this to trigger. Now, if our hit doesn't hit, it just breaks. So that's what that is. If it is true when it hits, we set our hit component to the physics object, and we target the grab component at location. This starts us to allow us to pick up the item, and we have our physics handle so that we have the interaction there so that it actually knows what to do with that object. Then we set that to is holding object true, and then we'll set the collision response on this channel for the item in question, for the physics object as it is, to a pawn and ignore. So this sets it so that we can manipulate it and also that it doesn't block our path. So we don't actually have collision for it at the time. And then we also add another modifier to this as set angular dampening to 10. This way, it doesn't start spinning around like crazy while we're holding it, because and also when we let go, this allows it for it to actually not fly off into the aether along with not spinning like a top. And this runs in tandem with another function we have down here as part of our drop, which our drop goes into our release component of our physics handle, and we set is holding to no, and then we set our collision response channel for pawn, and then we set it back to block, so it is now a physical object that blocks us again. And then we had to set it also over here to set its linear velocity to 0, so it doesn't fly off again. That was the main reason for that. Then we have a delay for a little bit of time, and then it also sets our angular dampening back to 0. So this gives us a subtle little stop so that we don't end up, so it looks a little bit better and it doesn't end up completely flying off and spinning like a top, but it still looks like it has a little bit of physics. And that is how our object pickup actually works for our puzzle. Other than that, I think that's everything as of right now. So this was a pretty cool, interesting level. There's a lot more I want to try to do with it. I definitely am going to be expanding on the concept, but this is as far as I've gotten for right now, and I had quite a bit of trouble trying to get this whole object to pickup system to work because I actually was working off reading through how other people code instead of just watching videos because I wanted to try to get a little bit more understanding of how all this stuff works. So, took a little bit longer than I wanted, but I'm definitely happy with the results.